Hello, welcome to our second part of relationships. Hopefully you read the instructions and did the Desmos activity already, turtle time trials. It's a cool little activity just to get you thinking about more relationships and data. This one in particular is distance versus time, how far the turtles run versus a certain amount of time, and it relates to their speed. So if you haven't done that, pause the video and go back and try this activity, this fun activity first on Desmos, and then come back here. But now that we're here, let's look a little bit deeper in this speed idea and how distance and time is compared. So we're looking at Lionel's walking trip. This graph represents Lionel walking to a friend's house. So if we just look at it, we want to make sure we read these variables so we understand what it is. So we're talking about minutes here and distance traveled. Okay, so how far has he walked? And you can see that he goes up here, so it means he's increasing his distance traveled, and then it flattens out, which means his distance travel has not changed. I think we should all know now that means that he hasn't moved, and then his distance travel increases some more. So let's answer a couple of questions about this. Let's identify the independent dependent variables. All right, so the independent variable is the one along the bottom axis here. It's time. And remember, time is almost always an independent variable. So here is a perfect example of that. Then the dependent variable is obviously the distance traveled. The distance traveled depends on how much time has gone by, not the other way around. All right, how long did it take Lionel complete his journey? So it looks like he's here, and then he walks along and he stops for a bit, and then he continues on. And I think it's safe to say he's reached his journey here at 2,000 meters, and it would take 20 minutes. It took him 20 minutes to actually do this journey. How long would Lionel have taken for the trip if he hadn't stopped? So this is the spot where he has stopped. So I'm going to suggest this. If he had gone along at this pace and didn't stop, he would continue along at this pace. So let's actually explore that a little bit. So I'm going to take a graph here. I'm going to make it orange. I'm going to start here and follow this path and say he didn't stop, and he would keep going along that path until he would get to the 2,000 meter mark, which to me is not quite halfway, maybe around 17 minutes would be my guess. So let's click on, there we go, 17 minutes would be a good guess. You might guess 16 and a half minutes or 16 minutes, and that's fine, right? But that would be one argument, that he would actually be, let's just get nice and perfect there. He would continue along and reach his point at 17 minutes, his destination, if he had continued along at the same rate without changing. Okay? But another way you could argue is, hey, if he stopped for 5 minutes and the whole journey took him 20 minutes, you could also say, well, it would have taken him 15 minutes. So that would relate to how fast he's traveling. So it says, how does the change in steepness relate to Lionel's walk? So of course, if the graph is steeper, that means he must be walking faster. So let's look at an example of that. If we looked at a graph like this, he would travel 2,000 meters in only 5 minutes. So that would mean he's going much, much faster, and the graph is steeper. Versus something like this, where he only travels 500 meters and it takes him much longer to do just that 500 meters. So this is less steep and obviously a lot slower. Okay, so the steeper the line, the faster it is. And we've probably discovered that in some of the other activities we've done. So was Lionel's walking faster before or after he stopped? So this is a great question. So we can see there's the orange line that kind of represents him before, and then he stops. And then the question is this line steeper? And I think if you take a look at it, it looks like it is steeper. Now, we've got the luxury of the technology here to sort of move this over and say, you know what, that's how steep the original line was. And you can now clearly see that the black line is steeper than that orange one. So I think it's safe to say that afterwards he walked faster. And that's how he makes up this time. Remember, our original argument was that it was going to take him 17 minutes. But if you take out the 5-minute break, it's only 15 minutes. Well, that's because he walked actually faster afterwards. So if he had not stopped and walked faster, he would have gotten there, obviously, at 15 minutes. Let's confirm this by using speed. So because we have this distance versus time, we can calculate speed. How do you calculate speed? Well, speed is distance divided by time. If you think about the speed of your car, it's measured in kilometers per hour. Kilometers is a measure of distance, time is hours, and this divide by is the per, kilometers per hour. So to do the math, it's right in the unit, kilometers per hour, distance divided by time. So let's do that on those two parts, before and after. I'm going to move this orange guy back here just to represent sort of the before part. Okay, so before, he is going to do the distance. So it takes him from here to there, the distance. So that looks about not quite halfway. Halfway would be 1,250 meters. So I'm going to estimate about 1,200 meters is about how far he travels before he stops. And then it took him 10 minutes to do that, 10 minutes to do that. And so we do that math, 1,200 divided by 10 is 120 meters per minute. So there's that division. Again, distance divided by time, meters per minute. It's not kilometers per hour. He's walking here, so it's meters per minute. And then afterwards, so let's examine after. So afterwards, he starts here, so he's at the 1,200 meter mark, and then he finishes at 2,000. So that's a difference of 800. So he goes 800 meters, but it only takes him 5 minutes to do this last little part. So 5 minutes. If you divide that, you get 160 meters per minute. And so now you can have the math to confirm that he is going faster afterwards. And this is one of the great parts about what we're studying here. And what we're going to do for our next unit is we're going to start attaching numbers to these graphs so we can be a little bit more specific. Instead of just saying he walks faster, we can actually talk about the speed and describe how much faster he's going. Finally, if Lionel wanted to reach his friend's house in 10 minutes and didn't stop, how fast would he have to go? Well, we could imagine this by drawing let's draw a red line here, starting here, and he wants to go and get there in 10 minutes. And we're assuming he gets to 1,200. Okay, so right there you can see that's what it would look like. So it'd be steeper, faster than either of these two lines. Not quite as fast as this green one, but that was just there for fun. So that red one there is what we're looking at. So for number 7, his speed again is distance divided by time. So the distance, he wants to travel 2,000 meters to get to his friend's house, and he wants to do it in 10 minutes. So obviously divide that and we get 200 meters per minute, and it clearly is faster than the other two rates. Okay, so distance versus time graphs and calculating speed allows us to answer and be a little bit more specific when we're talking about these type of relationships. All right. The next activity you're going to do, you're actually going to go to a Google Doc that I've created. So in the assignment, up in the top right-hand corner is a doc that looks like this. Okay, it's got some information and questions for you to fill out underneath. It's describing a Beetle and a BMW. So there's a Beetle and there's a BMW. One of these graphs, B1 or B2, is the Beetle, and the other is the BMW. So you're going to have to think about and study this graph and decide which one you think is the BMW and which one you think is the Beetle, and give some reasoning and then answer a couple of questions about that. So you'll be going right to this doc and typing in your answers right here. I think, or I guess in this one it's just whether it's B1 or maybe you think it's B2. You're going to type your answer in there and then explain your choice underneath. Okay, so you'll be going off and typing this right in here, and when you're done, you'll have a little turn in button up at the top for you to finish doing that. Okay, so that's all for this lesson. You can go in and try and answer the questions about the Beetle and the BMW, and you'll be talking about speed in that question. And that's enough for lesson 6. And I'll wish you luck in your culminating activity as we wrap up this unit. Good luck.